Hi everyone, welcome to day 9 of my cloud computing series. So today we are going to learn these topics. First is various medium access control protocol. Second, what is pure Aloha. Third, pure Aloha versus slotted Aloha. Fourth, carrier sense multiple access in computer. Fifth, CSMA and CD. And sixth, CSMA and collision avoidance. And seventh, Ethernet frame format. 8, token ring. 9th, network layer. 11th, class A IP address. And class B, class C, like 12th, class B, 13th, class C, 14th, class D, and all this we are going to learn today. Okay, so I'm going to my notes. So if you see multi access control, it's Mac. Okay, so there are three types: random access protocols and control access and channelized protocol. So we are going to learn this pure LOL and CSMA and CSMA collision detection and collision avoidance. Okay, so in Aloha there are two types: pure Aloha and slotted Aloha. And what are the data link? In data link there is logical link control (LLC) and media access control. These things are running in data link layer. Okay, pure Aloha is in random access control protocol. Acknowledgement is there. If you see there, we have learned yesterday only how the acknowledgement, if the message giving back like that, so it's like that. Okay? And LAN based, it is a LAN based, only transmission time, no propagation time. Okay, so if you see what is pure LOI, if you see this is your backbone or bandwidth, like bus topology. And it is connected by so many devices, so it will check, and if there is any nothing data is transmitting, then it will send their data. It's like that. So pure aloha and slotted aloha. If you see in slotted aloha, tra- anytime transmission. Okay, and it's like that. Career sends multiple access CSMA. There are one persistent, zero persistent, p persistent. If you see one persistent, what is one persistent? It will see a sense in there, it sends it there, like this device is sensing there. If message is not passing, then it suddenly send their data. This device, if you see this device is sending their data. If it's sensing, if there is no signal is passing, then it sends the data. But in this, what will happen if this device is also sending, but it far from there, and it's sensing and send. So what will happen? The collision will be happen. So in one persistent, collision will be there, and in zero persistent, what will happen? It will sense. If you see, it will wait after few minutes. After at 15 time, it will this will wait for 10 minutes, this will wait for 20 minutes, this will wait for 15 minutes. So it also in collision is less, but waiting time is so lot. So that's why it's not good. It's a zero persistent. What is persistent? It's a combination of those, or we can say hybrid of these two. So it's in this waiting also there, and continuous sensing also there. Okay, career sense multiple access collision detection. If you want to see there is no acknowledgement system, then like your message pass good. And if the like no acknowledgement is there, then your collision is happened like that. And if you see this example, if this in this message A passes to B, and it passes from 12, and take 1 hour to pass that. And the worst condition, what will happen? It's sent to produce send data at 12 p.m., and it's passing, and 12 clock 59 minutes and 59 second after B also produced. So this is the worst condition of collision. So this is like that. So this is the detection. And avoidance, we will avoid this by through this diagram. If you see this diagram, you will understand. Like first we'll say, we'll wait, see it's the first attempt or not. If zero attempt, it's yes or no. Then if say ideal is ideal, then it will that backbone or the bandwidth is ideal or not. Is yes, then it will go wait. or else no, then it will repeat sense, and after then it will yes, then it will wait. After wait, it will like DFC interface space, and after sometimes it will choose random, and after that also there is send RTS like is there is a one, and many are connected, and it's wait after set a time. After that it's also wait sometimes, so it's so many waiting. So it's like in this collision we are avoiding our collision in this. Okay. Ethernet framework format, it is data link layer. There is a preamble, SFD, and destination address and source address and length and data and CRC. Okay, CRC is like we have learned yesterday only, like detection or avoiding the what we can say in data. And preamble 7 MB in there, and SFD 1 MB 1 byte is 7 byte is 6 byte, like that. If you see, you will understand through this. Token ring, it's also a token use topology access control method used in token process, and it's a token ring in your unidirectional data is used in 4 MBs, like that. You can see um, piggy banking, backing and acknowledge is used, different Manchester encoding used. So it's like that. Format, if you say like that, frame format also there. If you see network, what will in network it use IP address, logical address, network host, like that. So it's not taking care of host to host or node to node. It take care of host to host, not node to node. Okay, not hop to hop also. So it take care of host to host, source to destination, machine to machine learning. If you say this like that, you will understand that. Fragmentation also there, congestion control will be there, and routing also there. So this all this thing take care of by network layer. And there is a class full. In class full there is class A, class B, class C, class D. And if you see, there is like if 1 0 to 126, then it will class A IP address, full class full IP address. And if you see node ID 8 byte and 24 other like host ID. And class B, it's like 28 to 91, it considered as a class B. And if you see, it's 16 bytes node ID and 16 byte host ID. In class C, 24 bytes is node ID, or we can say network ID, and other 8 bytes it's a host ID. Okay. And if 92 to 93 will consider as a, or we can say class C, class C, and class full IP address. Okay. And class D IP address, like that is range and all. And class E is usually default, and you can see 240 to 225 used for research only. So it's like that. And this is the last range. If you see class NN, like only first is network, after that all that is host. In the in these 2 bytes is network ID, and network ID in 3, in this 3 network ID, last is host. In the two network ID, 2 host ID, like that. And if you see disadvantage, you can learn that. So I hope I explained very well. So we will going to learn new topics tomorrow. Till that time, bye.